Hey, what's up everyone? This is going to be a pretty short video, just kind of an extension on our last video, and this is going to be all about simplifying trig expressions. So the first thing I'm going to do is basically take away our unit circle because we really don't need it. What we're going to be doing is we're just going to have some different expressions, and we're going to use our 6 trig functions. Let me get rid of that. So we're going to use our 6 trig functions, and we're going to use a lot of substitution essentially here, and we're also going to use our Pythagorean identities as well. And this is actually going to be very similar to something like this. Like if I had this problem, I don't know, let's say 6 divided by 4. Well, how would you actually simplify that? Well, you'd break it up or substitute different things, right? 6 is really 2 times 3, and 4 is really 2 times 2. And since I have these 2's up, one on top and one on bottom, 2 divided by 2 is 1, those will cancel out, and I'm just left with 3 over 2. So it's basically, and by the way, it's the same thing. If I have like x cubed over x squared times y, well, on the top, right, this is actually x times x, and then we have at the bottom x times y, and so these two x's cancel, and I'm just left with x over y. Whoops, I don't know where that line just came from. That's kind of weird. X over y. But anyway, but in this case, of course, we are not going to do this with just numbers and variables. We're going to do it with our trig functions. So sine, cosine, and then every other one as well. And by the way, one thing that you should note is that every single other trig function, whether it's like tangent, cosecant, secant, cotangent, these can all be written as in terms of sine and cosine. Okay, so when we're simplifying, many times we will like start, or one good strategy is to start by just saying, well, if there's a tangent, let's just rewrite it as sine over cosine. Or if there's a, I don't know, a secant, then let's rewrite it as 1 over cosine. Okay, so we can get things in the same terms, in like terms. Okay. All right, so let's go ahead and let's just do a couple of problems here. So this first one we're going to start with, and let me just grab a different color. Let's simplify this. So I have the sine of theta times the cotangent of theta times the secant of theta. Okay, so this is sine theta times cotangent theta times secant of theta. And again, you could think of this as like x times y times z, right? But in this case, these do share something in common here. But I'm going to rewrite these in terms of sine and cosine, okay? And really, I should have probably separated these a little bit. This should be like times and then times. But whatever, you guys get the hint. All right, so anyway, sine is already in terms of sine, so that's just sine theta. Cotangent, let's see here. Well, what's cotangent? Well, cotangent is cosine over sine, so that's cosine over sine. So just substituting, that's it. Times the secant. And what's the secant? Well, the secant is the reciprocal of the cosine, so secant is 1 over cosine of theta. Okay, and now that these are all in like terms, we can, since we're multiplying, right, this is actually sine of theta over 1, and then times cosine of theta over sine, and then times 1 over cosine theta. So let's start canceling. So let me grab a different color here. So sine and sine on top, sine on bottom, that gives you 1. Here's a cosine on top, here's a cosine on the bottom. And so what am I left with? Well, remember, these don't just cancel to 0. This is 1 times 1 times 1, right? So this whole thing here ends up equaling 1 over, well, maybe I'll just do both. 1 over 1, which is equal to 1. Okay? So the sine of theta times cotangent of theta times the secant of theta is actually just 1. Okay? All right, let's go ahead and let's do another one. Let's get rid of that. Okay. Next one up here. Let's do something a little bit slightly more difficult. This one is going to be the tangent squared of theta. And by the way, once you start seeing like squares and stuff like that, you should really be looking at these Pythagorean identities to substitute down here. Okay. But anyway, I have tangent squared theta minus secant squared theta plus 1. And let's go ahead and simplify this thing. All right, the first thing I'm going to do is I want to look for something that I could maybe simplify two of these things. Maybe like tangent squared plus 1 is actually equal to something. And actually, I'm already looking here. It is equal to something. Like if I rearrange this, right, let's move this 1 over. So this is the same thing as tangent squared theta plus 1 minus secant squared theta. Okay, and this tangent squared theta is, tangent squared theta plus 1 is equal to, down here, the secant squared of theta. So let's go ahead and we'll substitute. So this becomes secant squared theta. So that's secant squared theta minus, and then we'll drop that guy down, secant squared theta. And what is secant squared theta minus secant squared theta? Well, anything minus itself is equal to 0. There you go. So tangent squared theta minus secant squared theta plus 1 actually happens to be 0. All right, let's do another one. And let me make this bigger so it's quicker to erase. All right, there we go. All right, next one up here. Let's do cosine squared theta plus sine squared theta minus 1. And again, whenever you see these squares, and this is not always going to be the case, but I'm going to look to Pythagorean identities to see if I can use any of those. And in this case, cosine squared theta plus sine squared theta, well, that's right here. Sine squared theta plus cosine squared theta is the same thing as cosine plus sine, right? And so what are those equal to? Well, those are equal to 1. So let's go ahead and use those. So that is 1. And then I'm going to drop that down, 1 minus 1. And again, we get 0. So cosine squared theta plus sine squared theta minus 1 is actually equal to 0. All right, let's do another one. Flying through these. All right, next up here, we're going to try cosine of theta times the cosecant of theta. And I'll put a little times in there this time. Cosecant of theta divided by cotangent of theta. Now, I don't see any squareds in here, so I'm not going to be looking at the Pythagorean identities. I'm going to look at the 6 trig functions. And again, a really nice, what do you call it, a route to take is going to be to rewrite all of these in terms of sine and cosine, right? Because all of these can be rewritten in terms of sine and cosine no matter what. So let's do that. So this is equivalent to, and actually I'm not going to write an equal sign, just because, actually, let's do this. We'll do a little arrow, right? It's not equal to, it's, we're just changing, we're substituting here. So cosine is just cosine, so cosine theta. Cosecant is the inverse of sine, right? Over here, cosecant is equal to 1 over the sine. So we will write that as 1 over sine. So cosine over 1 over the sine, all over cotangent. And so cotangent is, in terms of sine and cosine, that is right here. That is the inverse, or I'm sorry, the reciprocal of tangent. So cosine over sine. So this is cosine of theta divided by sine of theta. Okay. All right, so let's go ahead and let's bring this down here. So cosine times 1 over sine is cosine over sine. And then we have divided by cosine over sine. So this is literally one thing divided by itself, which is 1. Now, if you don't really quite understand that, I could go backwards and put it back into terms of whatever these are equal to, right? Cosine over sine is equal to cotangent, right? So this could become cotangent. Again, this is not necessary, but if you prefer to think of it this way, cotangent over cotangent of theta, right? And that's equal to 1 over 1, which is equal to 1. Okay? 1. There we go. All right, let's do some more here. I've got another one for you. Let's erase all this work here. And again, this is all just substitution, just becoming familiar with your 6 trig functions and the Pythagorean identities, and then just substituting and following your typical algebra. So next one up here, we're going to do the secant of theta times 1 minus sine squared of theta. Now, there are multiple ways to do this. I could distribute this in right away if I wanted to. Multiply 1 times secant theta is just secant theta. And then what is secant squared I'm sorry, secant theta times sine squared theta, well, you would just write that, if I did multiply this, let's actually do this. Secant theta minus, and then secant times sine squared, well, I would just write it like that. Sine squared theta times the secant of theta, right? So don't combine them yet, okay? The next step here, if I'm doing it this way, would be to rewrite everything in terms of sine and cosine. So secant is the reciprocal of cosine. So secant is 1 over cosine of theta. And then minus sine squared of theta. That's already in terms of sine and cosine. And then times secant of theta. So that is 1 over cosine theta. Okay. And so at this point in time, we could go ahead and, I don't know, start putting some things together if we wanted to. But let's see, what can I do here? I could multiply, like I could change this a little bit. But honestly, it's really not going to get me too far. Yeah, this is starting to get a little hairy. So let's go back. Let's see here. Yeah, let's go backwards. Okay. And by the way, this is okay to do, right? But it just goes to show that some paths are not always created equal, right? This is getting a little bit harder. You would eventually end up at the correct solution, the correct simplification. But let's go ahead and show a better way of going about this. Instead of distributing, I notice here that this has a sine squared in it, or something squared in it. So I'm going to actually look to my Pythagorean identities, and I notice right here, this one, the main Pythagorean identity, sine squared plus cosine squared is equal to 1. Well, if I could rewrite this. If I subtracted the sine squared over, then that would be cosine squared theta is equal to 1 minus sine squared of theta, right? So cosine is equal to 1 minus sine squared theta. So let's go ahead and substitute cosine into this for this 1 minus sine squared theta. Okay, so let me get rid of all that. Whoops, went way too far. There we go. Okay, so let's go ahead and do that. So I've got secant of theta times cosine squared theta. All right, so let's go ahead and rewrite secant of theta now in terms of sine and cosine. So that is 1 over the cosine of theta, and now we're getting somewhere, times cosine squared theta. Well, if I multiply this, this multiplies into the top here, right? So I get cosine squared theta over cosine of theta. And if I had like x squared over x, then I would end up with x on top, right? And this is no different. Cosine squared theta over cosine is equal to just cosine theta on top. And there we go. And again, if we kept going with our original way, our original route, we would have ended up here at some point. But again, not all routes are created equal. We're just doing basic algebra here, and sometimes you can go down one route that actually makes it a little bit more difficult for you to solve. Okay. All right, now we are going to, I just want to show you how to verify an identity. And give me 1 second and I will bring this up. All right, guys, so now what we're going to do, what we call verifying identities. And so when we verify an identity, because these can take like almost any form, they're going to give you an equation, and we want to verify that one side is actually equal to the other. We're verifying this identity, and basically what you're doing is verifying that one side simplifies down to another side, essentially. Okay, so in this case, let's start with one. So I've got cotangent of theta times the sine of theta is equal to the cosine of theta. So again, you can kind of think of this as an expression like we were just doing, where before we would just have this one side and we would simplify it down. Well, in this case, we're going to simplify this one side down so that way we can confirm that or verify that it is equal to cosine of theta. So whenever we do these, we only work on one side. Whenever we verify an identity, we only work on one side and then get the other one. Okay, that's what we're doing here when we verify. All right, so let's go ahead and do that. So I'm going to actually put a little line down here so I don't work on this side over here, okay? So I'm going to do my normal thing, right? Same thing as simplifying. So in this case, there's no squared, so I'm not going to look at the Pythagorean identities. So I'm just going to use the 6 trig functions. I'm going to rewrite everything in terms of sine and cosine. So cotangent is the cosine of theta over the sine of theta, times the sine of theta, which is just sine of theta over 1. And so what I would do now is I would cancel the top and the bottom, or cross out the top or bottom, and we're giving us cosine of theta over 1, which is just cosine of theta. And so this is equal to the cosine of theta. And so I'll just put a little check, verified. Okay? So you can see we worked on one side to verify that this identity, that this is equal to the cosine of theta. Okay? All right, let's do another one. All right, next up here, we are going to do 1. We're going to verify that 1 plus tangent squared of theta divided by cosecant theta, cosecant theta times the secant of theta is equal to the tangent of theta. Okay, so again, I'm not going to work on both sides. I want to work on one side, and it's not always the left side, by the way. It's always usually the more complicated side is what you're going to work on, right? But anyway, so we want to verify that I'm going to work on the left side, and I'm going to get this thing simplified down to the tangent of theta. Okay, so let's go ahead and draw a little line here. Only working on this left-hand side. So first of all, the numerator. The numerator has a squared in it, and I can actually see 1 plus tangent squared theta is the same as tangent squared theta plus 1, and that can be substituted with secant squared theta because that's what it's equal to, secant squared theta. So on the top, I'm going to say secant squared theta. On the bottom, let's see here. What am I going to do? I'm going to say cosecant. Let's go ahead and, we're going to write this in terms of sine and cosine on the bottom. So let's see here. So cosecant is the inverse of sine, or the reciprocal of sine. So that is 1 over the sine of theta. And secant is the inverse of cosine, or I'm sorry, the reciprocal of cosine. So that is 1 over the cosine of theta. Whoops. Okay, there we go. And so yeah, that's really just, again, so sine times cosine. Okay, so where do I go from here? Let's go ahead and let's write secant squared of theta. Hopefully I don't run out of room. Let's write secant squared of theta in terms of sine and cosine. So this guy, secant squared of theta, is the same thing as 1 over the, what is that? Secant is with cosine. So that is 1 over cosine squared theta. Okay, secant squared theta. Remember, secant theta is the same as 1 over cosine. And if I have secant times secant, that's the same thing as 1 over cosine times 1 over cosine, or 1 over cosine squared. Okay, so 1 over cosine squared theta, and then divided by 1 over, I'm just going to combine these, sine of theta times cosine of theta. Okay, when I multiply numerator and denominators. All right. And yeah, I'm kind of running out of room here. So when I divide fractions, it's the same thing as multiplying by the reciprocal. So what I end up with when I multiply by the reciprocal, so I have the numerator, 1 over cosine squared theta. And you could write it, let me rewrite this as cosine times cosine. Cosine theta times cosine theta, just to be super explicit here, times the reciprocal of this denominator, which is sine of theta times cosine of theta, divided by 1. And now we have something. So I can go ahead and cancel. What am I going to cancel? I got cosine down here, and I got cosine up here. So that leaves me with 1 times sine over cosine times 1, which is sine over cosine. And I have run out of room here, but let's just move this over here. So that is going to be sine over cosine, which becomes tangent of theta, which is equal to that guy right there. So boom, it is verified. That was a bit of a long one there, right? Okay, let's do maybe just one more here. So let's verify the identity. And if these don't verify, by the way, sometimes they don't work, and you can say that no, this is not. I've not verified this identity. These are not the same. But anyway, let's see what happens here. So this is the tangent of theta times the cosecant of theta. Cosecant of theta is equal to the secant of theta. So I want to verify that I'm going to do the more complicated side. This side right here is equivalent to secant of theta. So I'm going to go ahead and rewrite this in terms of sine and cosine. There's no squareds in here, so we're not going to worry about that yet. So tangent is sine over cosine. And cosecant is the reciprocal of sine, so sine theta. And it looks like, yeah, these are going to cancel here. So I have sine on top and bottom, which leaves me with 1 over cosine. And if I rewrite that in terms of its reciprocal identity, 1 over cosine is the secant of theta. And there we go. So secant of theta is equivalent to the secant of theta. Check it off the list, and that has been verified. Okay, and actually I got one more for you. Let's go ahead and, yeah, we're going to do one more. This one looks a little bit more complicated. So I've got 2, actually it's not going to be that complicated. 2 minus sine squared theta minus cosine squared theta is equal to 1. Now, if you're clever about this, you know, and by the way, again, I'm seeing squareds in here, so I'm automatically going to be looking to the Pythagorean identities. The problem is it doesn't right away match up with any of these, but this is minus sine squared theta minus cosine squared theta, and here I've got positive sine squared theta plus cosine squared theta is equal to 1. If I could somehow get these negatives to be a positives, then I could substitute 1 in there. Well, let's pull out a negative. Why don't we put like parentheses around this, right, and pull out a negative. So if I do that, I'm going to say 2 minus 1 times, and if I pull that 1 out of there, let's put like that. If I pull that negative 1 out of there, I end up with positive sine squared theta plus cosine squared theta is equal to 1. And then, and again, you could kind of put this down here. But anyway, and now I have 2 minus 1 times this Pythagorean identity, which this guy is equal to 1. Sine squared theta plus cosine squared theta is equal to 1. So this is 2 minus 1 times 1, which is just 2 minus 1, which is 1. And that is equal to 1, and boom, there we go. We have verified that identity. Now, again, I want to stress that these do not always work. Okay, in this case, all of these examples, yes, they did work. Also, I want to stress that you should, when you're verifying identities, you're verifying that one side is equivalent to the other. So you are simplifying one side down to get it to be the same as the other one in order to verify that that's what it actually is. Okay, you never work on both sides. All right, so that's it for today. And yeah, just playing around with all of these 6 trig functions and Pythagorean identities. And just in case you guys are wondering, yeah, there are lots and lots of trig identities that we can create, different formations, and so there are like if you look up like a cheat sheet online, for example, with all of the trigonometric functions and identities, you'll probably have a full page to 2 pages of lots and lots and lots of different identities and expressions and all kinds of different things. All right, so that takes care of this lesson, you guys. I'll see you in the next one.